Hey, good morning. Pete, North Las Vegas. Today we're looking at a carbine buffer, and we're going to try to determine how much of the carbine buffer bumper should stick out past the spring when this spring is fully compressed into what they call a solid condition, where every coil is touching every coil. This thing is fully compressed on this buffer. How much of that bumper should protrude past the end of the spring? So on the TDP package I have for the M4, M4A1, they don't have a drawing for the complete buffer with the bumper and the weights and all that stuff installed. They break it down into individual components. So you can see in this drawing, all we're showing is the buffer body. So there's no bumper on here. Okay, so on this drawing here, we can see the buffer bumper and its dimensions. And like I was saying earlier in the other clip, everything is broke down into components. So we're going to have to consult 3 different drawings, and we're going to do some math. And then in the end, we'll be able to determine how much of that bumper should stick out past a compressed spring. So let's go take a look at the spring drawing now. Okay, so here's our carbine buffer spring, and most of the vital statistics are over here on the left, which we'll get to a little bit later on in the video, but I just wanted to show you that, we have to look at 3 different drawings to figure out what we're talking about in this video. Okay, so when I start crunching numbers here and we start really digging in deep, I'm not going to be using the tolerances. We're just going to stick with nominal numbers just to keep the math simple. But just so you know, there's a range, a plus and a minus range that all these numbers can be. So anyway, let's get started. Okay, so the first dimension we need to know to figure this out is from the spring location distance right here, where it butts up against the buffer head, to the buffer body, not the bumper, but the body. So if we come up here to the drawing, we can see that they don't give us that number up front. So what we have to do is take this distance here from the face of the buffer to the back of the buffer, which is 2.855. And then we have to subtract the distance here from where the spring sits on the buffer. And that happens to be 0.260. Like I said, we're not dealing with the tolerances, just the nominal numbers. So we have 2.855, and we have to subtract 0.260. So that's what I did here on paper. So that gives us 2.595. So this 2.595 number is from right where the spring butts up against the head to the back of the buffer body. Okay, so that's the first number we need. Okay, so here's our 2.595 number. You can see I don't have it held on here. It's kind of hard to do one-handed, but when I did this off camera, it came in really close, like almost exactly where it should be. So the next number we need is how much of the buffer bumper fits inside of the buffer body. And you can see they don't really tell you that. You got to take these numbers and do some more math. So what they're showing here is this 0.473. This is the part that's going to fit inside of your buffer body. So 0.473 of this bumper is inside here. So that leaves 0.4 on the outside. So that should come in at about 0.4 because all we're doing is subtracting this 0.473 from the overall length of the entire bumper. So 0.473 from 0.873, that leaves us with 0.4. So let's do a quick measurement with the caliper and see if that's anywhere near 0.4. So we can see that we came in right at 0.4. So those numbers panned out. So what we figured out from the previous clips is from the spring contact area here to the very end of the bumper, we now have 2.995 or something close to it. Like I said, we're not We're not looking at the tolerances. We're just looking at nominal numbers. So let's put the caliper on there and see if we're close to 2.995 from the spring location to the very end of the bumper. We came in at 2.8 using the calipers, but like we're saying, there's a tolerance here. Free length after setting, 10.7. So that's nominal. You'll find at some manufacturers the springs are a little bit, maybe just a little bit shorter or a little bit longer, which I'll show you here in just a second. But let's take a look at the specs here. Wire diameter number 3, 72 thousandths plus or minus 1 thousandth. Number of coils should be about 38. And this one here, number 8, that's an important one. That's the solid height. That's when the spring is fully compressed with all the coils touching each other. 2.847, that's an important number. So we said 38 coils. The one on top is Palmetto State Armory. The one on the bottom came from an ATI kit. And you can see there's quite a bit difference in length. They have the same number of coils. Actually, this one comes in almost a coil less. This is coming in closer to 36 than, or 37 than 38. The wire gauge is the same. So if I come down here and measure the Palmetto, we'll see we're right at 72, and the ATI is at 72. So even though these springs are different lengths, they have roughly the same number of coils. This one's just pulled apart further. So just because one spring's a little bit longer than the other, you need to maybe dig a little deeper to try to figure out why. So in either case, either one of these springs is good. We're finally at the place where we can crunch some numbers and try to determine on paper. Now you also have to check this. I'm not going to actually compress this on camera. It's too hard for me to do it one-handed and record at the same time. But if I were to fully compress this spring at the maximum 2.847, that's the mil-spec maximum. So if you can compress the spring a little bit shorter, good. But your spring is not supposed to be longer than 2.847 when fully compressed. So we take that 2.847 number, and remember we determined that the spacing from where the spring sits to the end of the bumper. So we're going to subtract this compressed number to this dimension here that we figured out. And that comes in at 0.148. So if I were to compress this spring and compress it as far as I can, that bumper should protrude past the end of the spring at 0.148. So a little over 1/8 of an inch, and you'll be in spec. If you have more than that, great. You don't want too much more than that. Like I said, there's a tolerance for all this stuff, but the minimum at nominal, 0.148. So if your buffer bumper sticks out past the spring, when the spring is fully compressed on the buffer, that right there is about 0.148. So that's about how much bumper protrusion you would want past the spring to be in spec. So if you had a little more, you'd probably be good. If this thing was sitting, closer to the spring, or if you managed to be in here somewhere, you got a problem. All right, well, hopefully I didn't get anybody confused and carry on too long about this. Probably more than anybody really wants to know about their buffer spring and bumper relationship. But if you got OCD like me, Pete, North Las Vegas, over and out. Bonus clip on your mil-spec buffer tube. The inside depth dimension is right at 7 inches. And that's your bonus clip for today.